So we're about to start in about 2 minutes. So I'm Nikki, community builder at SGInnovate, and we're very happy to have been here today with Quadrant Protocol. So just a bit about SGInnovate. We focus a lot of deep tech, and blockchain is one of the major aspects of deep tech that we actually focus in here at SGInnovate. So we're very happy again to have Quadrant Protocol share with us how their protocols can actually help the community do their jobs better. So without further ado, I'll just hand the time over to Mike. So, do check out SGInnovate websites and attend our events. And we're very happy to have all of you here today. So, Mike, please. Thank you.
Thanks very much for that introduction there. It's great to see everybody here. I'll give you a little bit of a history about Quadrant Protocol, what we're up to, and a little bit of background. But it's sort of ironic here that I'm sitting here on stage at SGInnovate. 4 years ago, I first came to Singapore and met up with Steve Leonard at an IoT conference and told him about my plans and how I was going to build this platform for transacting data. And now 4 years later, here I am in front of a room full of people at SGInnovate talking about our next generation protocol. So yeah, a little bit of our history. So like I just mentioned, 2014, we came with a mission. And the mission was to enable the data economy, make it easier for companies to transact data. My background at Samsung and previously with 3G telecommunication network infrastructure, we'd always see a lot of data going through the network. And people were trying to figure out what to do with that. How can this data solve problems? And so in 2014, came to Singapore to launch a company called DataStreamX. And what DataStreamX did was we built a platform and released in 2015, which enabled people who were trying to sell data and people trying to buy them to meet, to connect. And by 2015, we launched that platform. By 2016, we became VC-backed by Wavemaker and backed by the NRF, the National Research Foundation, to further our development and commercialization of our platform and bring more data providers and producers and consumers onto the platform. By last June of 2017, we had over 5 billion records going through our platform per month, being transacted between parties. And then by March of 2018, it was over 20 billion. And what this did, it gave us a good sense on what's going on in the data economy. It gave us an idea of what are some of the issues that are faced by people who are trying to monetize data. And more importantly, the issues that face people who are trying to get insight from data. What problems were they trying to solve? And what was hindering them from solving these problems? If you're not in the data space, actually I should ask, is anybody here working in the data space? It could be ad tech, it could be any data scientists here. Does anybody actually work with data on a daily basis? And it's only when you work with data that you start to realize all the issues. Hey, we got 1, 2, 3, so at least 3 data people in the audience, so that's perfect. Well, I'll teach you guys a little bit about it and what are the issues we saw. So this looks pretty complicated, but let me just explain it. On one side, you have something producing data. This could be your phone, it could be your laptop, it could be like when you swipe your credit card, a POS machine. Data is being created everywhere. And as Singapore becomes an even smarter city, it's one of the leading smart cities in the world, and as we put more and more solutions out there and as companies become more data-driven, they're producing more data. On the other end, you always have somebody who wants to consume data. They're trying to find insights. But what happens is there's this messy thing in between of resellers. There's all these middlemen in between the data producers and the data consumers. But there's a reason for this. In the data space, you can't really connect the producer all the way to the consumer. And I'll give you an example. Procter & Gamble, they're a global company. If they just want to know how many tubes of toothpaste are being sold, a very simple question. They don't want to go ask 5 billion people how many tubes of toothpaste you bought. Even though we produce data when we swipe our credit card or we go to the store, they don't want to know, hey, what was all in your shopping cart? But Procter & Gamble does want to know by country how much toothpaste is being sold. So what you have is all these people aggregating data. You have like MasterCard, Visa, Amex, who can give insights. You have stores, loyalty programs giving insights. And all this data is aggregated. And the end consumer, like a Procter & Gamble, will take these data insights and then use it to drive their business. And so the data economy is full of all these third-party resellers, from market research firms to now data analytics firms. Then the issue is that this supply chain isn't very transparent. So what's limiting the data economy? What are the lessons that we learned from actually interacting and basically commercially selling data? Well, the first thing is cross-contamination. When people are looking for data, they have to go to multiple parties. They go to multiple resellers. They go to multiple market data providers. But what happens is a lot of this data overlaps each other, and you can't really understand where this data comes from. And sometimes you're purchasing the same data. So actually, one of the reasons we started Quadrant Protocol was back in 2017, we were transacting with 5 billion data records. And with that, our buyers were looking for more feeds. They wanted more of the same data, but they wanted more sources. And so we put a call out to all the vendors and said, hey guys, we got buyers are looking for the data feeds. Do you want to sell? Do you have these products? And in 1 month, 4 providers came to us. And Sharik, our big data engineer, noticed that 4 of these feeds were about 90% the same. 4 people who were trying to monetize their data sets all pretty much had the same data. And so we said to them, do you own this data? Like, of course, yeah. I said, are you sure? Like, yeah. Where did you get it from? Oh, from our own systems. Well, due to NDAs, we couldn't tell them, hey, by the way, these 3 other providers are also selling the exact same data set. But that's when we noticed there was an issue. There was no transparency. Companies were basically layering their data with other people's data and claiming it to be their own. So cross-contamination was a big issue when people were trying to transact data. The next is compliance. Governments and people are becoming smart. They're realizing that you have to understand the whole value chain. In 2015, if you ask some people who were purchasing data and you said, where did this data come from? Where was the exact source? A lot of people would say, I don't know. I just bought it from them. Then we had Cambridge Analytica. We had the big blow up of Facebook, and the supply chain was very murky. Where was the data going to, and where was it coming from? So governments, regulation with GDPR, compliance is becoming a very, very important thing because the power that data holds now, well, we see it. Did it rig an election? Is Donald Trump in power due to the usage of data? And so compliance is becoming a #1 topic for governments and for businesses. Because businesses, they want to solve real problems. They don't want to be on the wrong end of regulation. And so compliance is a very big issue when it comes to the data economy and the data supply chain. And lastly, disparate sources. There is no one person that has data. Everybody in this room might think Google has so much data. Think of all the vast data centers they have. They must know everything. Well, they don't have Apple's data. Same with Singtel. You might think Singtel is a very powerful telecommunications provider. They must have all the data on Singaporeans. Well, no, you have M1, and you also have StarHub, who have their own data sets. So in the world of data, no one has perfect data. There is no one provider who has a global vision of everything and can solve everything. So the way that data is consumed and the way we look at it is that there's a lot of different fragmented suppliers. And as more companies generate data, that becomes more and more fragmented. And it's only when you start combining these data sets can you find true insight. So what we're doing here. And so as I mentioned in 2017, we noticed that there was an issue with transparency in the data supply chain. We noticed that it is a very, very murky place, and it was murky on purpose. Companies would purposely try to hide their data sources because that's their only IP. Without that, data can become commoditized. That it was incentivized for the providers to sort of hide where their data comes from. And when you do that, when you don't show where your data comes from, that enables you to do a lot of things that aren't above board. You can make up data. Data can be faked all the time. We see it. We've seen it over the years. Companies coming to us with vast data sets, and when I ask them where is this coming from, they'll either hide their sources, Or we've actually found that some companies actually just make up the data, like transaction data, and that they actually just have things generating data, which is really useless. That's not what people want to consume. And so this whole murky data economy, we wanted to basically shed some light on it. And that's why we have a blockchain-enabled data economy. So what do we want to do to make it, to improve, to make the data economy better, make it easier for companies to transact data? The first thing is provenance. Blockchain is fantastic for that. Blockchain, you can trace the sequence, see where things come from. By being transparent, you can see the source. And so this is one of the first things that we wanted to enable. Second thing is authenticity. Blockchain, being an immutable ledger, allows us to be able to stamp data and make sure that the data that when you consume it, you can trace it back to what it looked like when it was first produced. We'll show a demo of this in a little bit later on. Other characteristics we have is that trust, because it's public. By putting a public ledger out there, it makes it much more difficult to fake things because everything is up in the public. Security-wise and integrity as well is that people, the systems in place, what they allow for is if you're a data vendor and you want to be, say, above board, by entering into a non-transparent, a public ledger, you basically are bringing integrity to those providers. You're separating the ones who want to be in the murky side of the data economy from those who actually want to be transparent on where they get their data from. So what does this all look like? How many people have been to our website or read the white paper? How many people are? 1, 2, 3, 4, 5. Hey, 5. That's good. You can ask questions later if this is all new. So when you look at how companies transact data and where data comes from, on one side, you have what we call the nurseries. Nurseries are what produce data. It's your laptop there, it's the phone. This is where data comes from. It's the source of data. And if you're in IoT, it could be a sensor. If you're a business, it could be your cash register. If you're on your phone, it could be a video. These are the nurseries that are producing the raw data. But raw data alone is pretty useless. So what we have is what we call the pioneers. Pioneers bring data together, and they make products of it. They make something useful that people want to consume. The same data from a phone can be used in many, many, many different ways. Let's take location, for example. On your phone, everybody has GPS. Your apps are producing live data where you are. You're all sitting here right now. Your phone is beeping this off to Google, so Google knows that you're all here. They might even ask you when you leave, hey, what did you think of this venue? But that location data that's being produced by your phone, many companies take that, and what they do from there is they make products. It could be a company it could be a company looking at consumer goods. So they want to know, how many times you go into a Popeye's chicken or you go to a Pizza Hut, and they're analyzing that data and providing marketing insight into how people consume food. If you go to Popeye's, what's the chance you're going to go into a Starbucks within the next 2 days? That same location feed can be used by a hedge fund who wants to understand how many people have gone into a Lamborghini dealership or how many people have gone to Santosa's casino, because they're looking for alpha. They're trying to find out the popularity of places and investment decisions. The same raw data can be used by different companies to solve different issues. And that's where the pioneers come in. You'll see a lot of these companies coming out that they make solutions from there and they sell this data. Elon's is where things get really interesting. Because data is not really just about, I have data, you want data. Data really doesn't work that way. What it works on is like, I have data, what problems can it solve for my company? And we've actually seen over the last 4 years in Singapore, the ecosystem change drastically. We see companies creating innovation centers, building out data science teams, and what they're all trying to do is solve problems. They need the raw data to solve problems for their business or organization. And lastly, we see a lot of startups coming out. People who are doing machine learning, doing AI, but what they always need is more and more data. So Elon's in our ecosystem are these companies, are these centers, are these people who are looking to build new products by joining data. Because once you start joining different data sets, you start seeing the power of it. You start seeing what you can actually get insight from. So Elons are these companies. So if anybody here is in a company and they're trying to create new solutions, that you would fall in that category. Last thing is data consumers is the end companies. The people who actually end up implementing are the last step, usually the purchaser of that data. Sorry, always pointing the wrong way. Okay, how many people are technical here? I was on here last week. Wow, there's actually about 7 or 8. That's great. I won't go into this entire slide. But what we got here is sort of how our ecosystem works, how everything comes together. On one side, we have a producer client. What that is our client, when somebody's generating data, they'll enable the Quadrant services via a client. In the center, you have the blockchain, which basically is that immutable ledger for all the transactions. I'm actually thinking I'm going to skip over more of this one because it's probably a little too complicated to explain now. But what I'll do is we'll go into some samples of how we actually use our ecosystem to solve problems. So one of the key things with this, our testnet is actually live. For us, we've been building the solution since last August, and we started already implementing this for our commercial clients. So what I'm going to do now is talk about that. So our testnet right now, our throughput right now, we can process almost 1.92 terabytes of data can be put into our system per minute. Now, if anybody's in blockchain here, you're going to know one thing. The data is not in the blockchain. So what we do is that we provide the blockchain enables services for data, and the services that we're enabling have this much throughput right now. Our producer clients can stamp almost 500 megabits of data per stamp right now. I'll explain the stamping client in a second. We're file type, we're agnostic, and so depending on when you're transacting data, we can transact anything from a video to a picture to a relational database to just flat files. And so for us at DataStreamX, most of our clients are streaming, meaning that it's data that could be coming in every 5 minutes, every minute, every second. That's really what we're used to processing for our clients. But our systems Quadrant Protocol allows for any type. And we're going to show a couple examples of different types of data going through our system in a second. And the last thing here is that it takes about 60 seconds when we process a stamp. I think my next slide is a stamp. Let me see here. No, Guardian nodes. All right. So being a blockchain, we use POA. Which is proof of authority. So what that does is proof of authority secures our blockchain. And so we have Guardian nodes that basically create the blocks to ensure that, basically is our block creation. We basically put them all over the world to ensure that if something goes down, we have a backup there. So what's next here? So actually, let me go in. So before we go into that, so what's next here? So for Quadrant, what we've done is we created a system that enables companies to transact data in an authentic manner, that allows companies who are producing data to basically put it into an ecosystem. And what it allows for when companies are trying to purchase it, they can now refer to our the stamping client. Basically the stamping. Anyways, consumer client. Actually, I'll talk about that in a second. I'll wait for the demos. I'm trying not to get too much into Sharik's part here before we go to the demos. But just in general, what we've done is that for Quadrant Protocol, we've created a network of partners globally, which enables us to basically roll out. One of the great things about being a blockchain company is that you can enable from day one a partner network that enables us to basically expand our mission of Quadrant. We've put together a global set of partners, and I can take photos here. And one of our next steps here is that we're working with IMDA. Last month, the minister announced our partnership here. So what we're doing right now is on top of Quadrant Protocol, we're enabling a microservice and AI layer. What that allows for is that companies who are creating new services are able to build it on top of our platform. One of the biggest things when you're making data available is not making the data available, it's also what services you can put on top. So we've partnered with IMDA to basically enable Singapore AI companies, microservice companies, to build services on top of our data stores. Because we have vast amounts of data, that a lot of people who are creating new services are looking for access to this. And so if anybody's in the room who's actually working on creating new services. So I'll give you an example. If you are doing data cleansing and you're using AI or to identify anomalies and you want to provide this as a service to companies, please come do talk to us. We're looking for these innovative and unique solutions that we can help bring to market with you. So yeah, so if anybody is in that sphere, please come talk to us. Okay, so over the next 6 months, what we're working on here, the first thing is our mainnet launch. Everybody always wants to know, because a lot of times these talks, no one actually talks about a product or when the product is going to be out. Our testnet's already out, and our mainnet, we're just doing the last security verifications, and it'll be out within the next 4 to 6 weeks. From there, we'll be releasing our next version of the Block Explorer, and then Data Smart Contracts will come next in the fall. What Data Smart Contracts are is that nesting. As I mentioned, that when you have a data producer, there's many different layers in between prior to it actually getting to the end consumer. What our Data Smart Contracts are going to is enable people to continue that pattern. You have middlemen. Middlemen add a lot of value into the data supply chain. But what we're going to be doing is with the Data Smart Contracts, you'll be able to trace the supply chain. And this is very important because when you look at data, middlemen are always going to be there. Like I mentioned, Procter & Gamble will never go to every single person in this room and say, I want to buy your data. I want to buy your anonymous data. It's not going to happen. It's the reason why it's too costly. The individual person's data is only worth pennies on the dollar, or say pennies on the pennies. It's very minuscule. And so what we'll always have these middlemen who are going to be aggregating. And what our Data Smart Contracts do will enable the transparency between each one of these purchases. So then when the end consumer purchases the data, that they'll be able to see all the modifications or all the steps that it took to get the data from the individual device, the nursery as we call it, down to the end. From there, we're going to be creating a UX UI for a constellation creator, so actually mapping data together. Data can be very technical, but we're actually working on trying to make a UX that's going to make it very easy for companies to be able, and companies and individuals to map these data sets. And lastly is the Data Smart Contract Manager. That'll be released shortly after. Okay. This is my last slide. I'm not sure how much I'll go into it because this is what Shariq will go into. So what does it look like when somebody is actually producing data? On this side, you have a location data vendor. This can be anybody. This could be Uber. This could be Grab. This could be the Wi-Fi in here. A company that's basically trying to monetize their data. So what they usually do is that they'll send their data onto AWS, and then actually, let's go up to the top, is that usually what happens, somebody sends it to S3 bucket, there's a scheduled delivery, and then the buyer consumes it. So it's a very simple, on the top, you see a very simple transaction. You have a data vendor, they pass it over to the data buyer. Well, what we found is that, and what our new architecture is that you'll see is that we actually then, before we send data over, before it is going to another buyer, the data vendor will actually stamp the data. What they do is they take a fingerprint of that data and then put it into our blockchain. So if they're consuming it now, or if there's somebody 10 years from now is consuming that data, they can always check on the public ledger what the state of the data was when it was produced. So I'm going to give a real example of this. I'll leave the company's name out, but We signed a new data vendor, and like, why, I'm going to explain why this is important. Why do companies need to stamp their data? We signed a new data vendor to come work with us at DataStreamX. And they have historic data. They have like 20 years worth of data that they wanted to make available. And so we said, okay, great, you can come on. And this is terabytes and terabytes of data. And I said, okay, we signed the contract, and then they shipped us the data. They shipped it to us in the mail, in a box. This is a billion-dollar company, multi-billion-dollar company. And they shipped it to us in a box. So I got this thing. I had no idea what was at my house. And so I opened up this box, and it just drives. So now we were expected to, put it into our systems and then help them monetize it. Is that data in the correct state? I have absolutely no idea. Has it been tampered with, either maliciously or non-maliciously? I have no idea. And so that simple scenario, you can see if all of a sudden now somebody's taking this data and making financial decisions with it, using it, so like what it was stock data, ticker data. And so if somebody's making business-altering decisions based on what this data is, I can't verify if I know it's 100% correct. But using Quadrant Protocol, what we do is when data is produced on this side of the equation, as soon as it's produced either from your, in your server, in the future we'll put it directly to the phone, is as soon as it's produced, we can stamp that into our chain. So if that data is mailed in the mail and the next day or like 10 years from now, there'll always be a public ledger on what that fingerprint is. And so what I'm going to do is I'm going to give it up to Sharik here, who's actually going to show you a demo of this actually in action. Thank you.
Thanks, Mike. Hello, everyone. I'm Sharik, a big data and blockchain engineer from Quadrant Protocol. I'm working with DataStreamX for the last 3 years. Over the time, I have designed and developed many solutions for APIs, SDKs, data pipeline, and big data solutions to handle terabyte of data per day. So you have already heard about the story. You have already heard the story about Quadrant Protocol. How it all started. So there was a time when I was handling a terabyte of data for one of the clients of DataStreamX. Working with that data, we noticed a couple of things. First was the data producers. They were not getting enough credibility for their data. Their data was being copied easily and they were losing business. On the other hand, data buyers, they were getting fake data. And these data, that were not adding value to their business. Even the algorithms, these were not generating helpful insights that can add value to their business. There was cross-pollination, overlapping of the data. And to have full coverage of the data buyer, multiple data buyers, they were still buying data from different data vendors just to have full coverage of the data. That means paying multiple times for the same data set. Like Mike said, the whole system was murky. There was no transparency. And we wanted to solve this problem. And this led to the creation of Quadrant Protocol. Today I'll be showing you the demo of producer client and our consumer client. So before going into the demo, let me talk about our producer client. Our producer client is one of the major pillar of Quadrant Protocol. This can be used by the data producers. What it does, it solves the problem of unauthentic data and bring transparency to the data ecosystem. Right now, we will see how it solves. Right now, our client is available in Java programming language. We will be releasing support in other programming languages soon. For this demonstration purpose, we configured our client with AWS services. So here you can see we have used S3 as a storage solution, but our client is storage agnostic. It can work with any storage solution. In fact, we will be releasing support for decentralized storage like Blue. Then we have used Lambda to execute and run our code. We have also used CloudWatch. CloudWatch will give us the logs generated by our producer client, and then we have our block explorer. We will look at the transactions generated by our blockchain into the block explorer. So without wasting time, let's go into the demo. So you see, this is one of the data feed for one of our client, and we have live data feed coming every 3 to 5 minutes. And our client is actually an event-based client. So the moment data file comes in, the code gets triggered. And the moment data file comes in, that information gets stamped into Quadrant protocol. Stamping the information means we are publishing DNA fingerprint of the data into Quadrant protocol. What does that mean? We publish hash of the data and metadata information, and these informations are there in the protocol. Like Mike already discussed, we are not storing data. The original data is still residing into the client's premises. So after every successful transaction, we get a transaction hash. Okay, Roger, can you go back? So after every successful data stamping, it returns a transaction hash. So see, this is a transaction hash, and this hash is actually coming from our data stamping smart contract. Wait. So here, you can see that this is the information file, data, and this has information about the block hash, the block number, and everything. So let's copy the transaction hash and go back to the Quadrant. We will see that whether it exists in the Quadrant protocol or not. So yeah, this information exists over there. See, it has everything like the timestamp and the block it got mined. So this is how a data producer, they will be able to prove authenticity for their data. The moment this information came into blockchain, no one will be able to edit this information. No one can delete this information. And as a data producer, they can always refer back and show the authenticity and provenance for their data. So this was the producer client demo. Let me walk you through the consumer client demo. So before going into the demo, let me give you a brief idea about consumer client. So the consumer client will be used by data buyers. This is a tool, a very handy tool for them to verify the purchase data. So let's go to the demo. Yeah. So let's suppose that this is the location where the data buyer is getting the data. And yeah, so let's put that data over here.
Can you unpause easy? I want to see.
Oh, okay, sure. So let me explain that. What is inside the DZ file? It is actually a location data file, and this has information like latitude, longitude.
Yeah, I know. But
Yeah.
can you untie? Can I take a look?
Yeah, sure. Roger, why not you unzip that file? Okay, maybe we can talk about it later. I'll show you the everything. Okay, so this is a location file, and it has information like latitude, longitude, device ID, country information, and this data is actually used by the location intelligence companies. So, did we upload the data? Yeah, just put it into the consumer client folder. Sorry for the problem. So, okay. Finally, now the file is getting uploaded. So this client, the consumer client, is also a event-based application. So the moment file comes in over here, this data, we will be creating hash of the data, and the application will be looking the hash into the existing blockchain. So if that hash is available in the blockchain, or whether that hash is available in the blockchain or not, so we will see. So okay, 74%. Come on. Looks like the internet is really slow here. So this is how we are. Oh, finally. Okay, we got the information. So the moment file comes in over here, this information will be compared along with the existing file information into Quadrant blockchain. So let's go to the CloudWatch. Let's go down, look for the latest logs. Yeah, so just if you see that these logs are coming from our consumer client, and it has the informations like the hash of the data, and go back to the status, this side. So here you can see that it says that the file already exists, and previously there were 9 versions of this particular file. So people will be able to verify the purchase data. If there is no file, if the information doesn't match into the Quadrant protocol, it will say that no versions found or no information found. So in this way, the data buyer, they can always verify the purchase data file, like okay, whether it is authentic or not. Yeah, and that is the end of our demo. So so just now we learned how we evolved from data stream X to Quadrant protocol, and and how our producer client help data buyer to verify the purchase data, and how our producer client helps the data producers to provide authenticity and provenance for the data. Now for the next part, I will invite Roger. Roger will guide you through the real world use cases and will talk more about the usage of our producer client and how to tackle with the fake data.
Thank you, Sharik. Good evening, all. My name is Roger, and my focus on Quadrant is more on the data science and machine learning operations. I also contribute to the Quadrant blockchain by prototyping and developing the smart contracts. Working in Quadrant protocol was a huge learning experience for me because my exposure to both data science and blockchain ecosystems has boosted my learning curve. It made me to learn further, to research more about how these two technologies can coexist together. Now, few moments ago, you saw Sharik walking us through a demo of how Quadrant's producer and consumer clients work. Now, I'll be explaining you with a real-time use case on where these clients can be actually applied and what is the value add that it can provide. So before that, one of the problems we see in this data economy is the unauthentic data. And the thing is, people started using AI models to generate these kind of unauthentic data. One of the classic examples is deepfakes. So I could show you a real demo, but I won't be using real-time data because it would be so boring. So I'm going to take a video content. So that would be the data, and I'm going to explain where it can be applied. So before jumping on to the demo, how many of you guys know here about deepfakes? One guy, Mike. Okay. 3, 4, okay. So anyways, let me explain a bit about deepfakes here. So if we had watched the movie Fast and Furious, during the last days of the shoot, like few days before the days of the shoot, one of the leading actors, Paul Walker, tragically passed away. He met with an accident. So what the crew needs to do was, the crew brought in Paul Walker's brothers, made them to act, and swapped their face with Paul Walker's face. And this is a lot of technical work. I mean, like, people need to use a lot of CG, and they need to spend a lot of man hours in order to swap these images. Deepfakes is a deep learning based application that performs the same thing within minutes. And it doesn't require any technical expertise. So I could wear a suit, stand in front of a camera, talk something antisocial, or say something like Justin Bieber's voice is more soothing than Freddie Mercury, which is also antisocial, and swap my face with Barack Obama and upload it to YouTube using deepfakes. And this could create a lot of havoc. So, and the worst part is, deepfakes is open source, and it is available in the form of an app. So it is like an inch closer to be getting mainstream. You see people faking pictures in the form of Photoshop right now. Like few months from now, you will see people faking videos using deepfakes. So how do you solve this problem? One way is to use Quadrant's producer and consumer client to stamp the data and put it onto the chain here. And think of it like, you can relate this to issues happening in your everyday life. So say you own a piece of land, and someone files a case against you saying that is their land. What do? You show an authorized paperwork saying that land belongs to you. Stamping is more like a cryptographic paperwork that tells you that content belongs to you. Okay? So we will be showing up a live demo right now. So consider this scenario where I'm an independent content creator, and I will be sending out a video file to a broadcasting company. So they were going to broadcast it on a Saturday Night Live show. So I created this 10-minute content, not literally, I mean, I'm just going to show it to you right now. So let's see what the image is. Okay. As you can probably guess, that is a fake person imitating like a Putin, like a shirtless Putin. So yeah, for this scenario, okay, I created this content, I'm proud of it. Okay, now say like I send it to a media company, like say, like BBC or NBC or something like that. Okay, Saturday Night Live. So they're gonna broadcast this on a Saturday Night Live. So you guys are ready, like with your beer or some drink, waiting for this content to be watching. So once you see it on a Saturday night, you're gonna see the other video, which is okay. Can you guys notice the difference here? I mean, just want to know. Okay, let me play that again. This is actually created, this video content was actually created with the Deepfakes app. Yeah, for your information. Okay, I'll show you the real versus fake comparison side by side to know what exactly happened here. Sherry, can you go back? Okay, on the left side is a real comedian from SNL, and one random person, not me, okay? So we used Deepfakes app and swapped his face with Vladimir Putin, okay? So say if I was the independent content creator and I sent this video to a broadcasting company expecting the video to be broadcasted, and all I see is a fake video, the positive things that actually could happen is SNL could get a more TRP rating, the video would be more funny. The negative things that can happen would be, I would be hunted down by US government and Russian government, and I might need to change my identity and go to another country for the better. So how do I stop this havoc? So this is a funny case here. So in real time, people could fake celebrities, politicians, and they could say, they could make those celebrities or politicians to say any form of thing and upload it in social media to that. So what we are gonna do is, as a content producer, I am going to stamp the real data created using Quadrant's producer client here. So in this case, we have stamped our data already. So it's out in the Quadrant net. Now say if the receiver receives the modified video, the fake video, as a receiver who is going to broadcast that video, he needs to verify that the data is authentic, it's not modified. So what they do, the receiver would be using Quadrant's consumer client and check whether it is verified or not. So we would be uploading that fake video. So here in this case, the content broadcast creator, the person who's going to broadcast that content will be uploading this video to check whether if it is verified or not. Okay, so here we are uploading this fake video. And one key thing to be noted here on the side thing. So as a producer, one needs to take note that you should stamp your data at the time it was created. At the time it was created, not at the time it is being broadcasted, because the time in between, anyone can fake that sort of a data. So as soon as you stamp the data once it is being created, it is good. Like it gives you a proof that, okay, you are the sole owner of the data. Okay, so now this is being uploaded into the consumer client. Now I go to the logs here and check if there are any entries. As you can see, since it's a fake content, fake video, the hash generator would be different. And we would look for those events here. Okay, as you can see, the stamp is not found on Quadrant, which means there's a hash mismatch. So as a content creator, I would be skeptical on broadcasting this video. I won't do that because it didn't come from, I can't find this hash into the Quadrant net, okay? Consider an alternative scenario where the content creator gets the actual content that is supposed to be uploaded, the real content without any modified data. So let's upload the real file and verify that. Okay, so once it's being uploaded, we're going to check into the logs again to see if there is a match. Okay, refreshing the events. Yeah, as you can see, the stamp says the single version is found. So which means the content actually matched with the owner. And the best part is it shows the owner address, the owner of the content creator. So which means if I could trace back and say like, okay, hey, the content come from this guy. Okay, fine, it's valid, it's authentic. Okay, so I can broadcast this video. So the Quadrant's producer and consumer clients are simple yet powerful tools that can be used to stop fake data that's out in the public. It can be fake images, it can be fake text, or it can be fake videos. It can be stopped. So that is the end of the demo. Thank you very much for your time and attention. I'll be handing the mic to Mike Davey. So thank you.
here again. Can you help us to understand how does Quadrant
Switching lights on here.
Yeah.
So what we're doing is that we're enabling services to go on top. And the reason is, so third parties will be able to create authenticity algorithms that will check to see the data stores, if they're authentic, if there's duplication. And the reason why that is, so when you look at data authenticity, like you're talking about the actual data, when it's actually created, when it's created, is that authentic? Every single data set will have in different verticals will have different different ways to verify if it's true or not. And what I mean by that, if you have a sensor, a temperature sensor, it would go under like a temperature sensor, like an IoT sensor for this building. To check if that data is authentic is very different than if you're trying to check if a handset data is authentic, or if you're trying to test if like somebody's credit card transaction data is authentic. So our protocol will enable people to build services on top of it, to run algorithms to check for duplication, if it's across different parties. So we'll be building, allowing third parties to create different algorithms that can then test, or what you're talking about is if the data itself is authentic. What the protocol does is, right, is this is timestamping on when it was created, this was the state of the data at the time of creation.
don't mind on you. So my second question is, are you guys like storage provider agnostic, or are you just signed up to Luzelle?
No, so we're agnostic to it. So what we've learned is that depending on the type of data will depend on where you store it. Something like Luzelle is like a key value store. So there's only certain types of data that application is really good for. But like they're not good for video, right? So somebody would use could use S3 or other providers. So we are agnostic to the storage mechanism. But yeah, we do integrate with Luzelle. So if people are looking for that type of storage, we'll be able to use it.
So, good evening. Wanted to, oh my, sorry.
No worries.
With what you showed, you're just hashing the file, which isn't data. A file isn't data. A file is a file. So, are you actually verifying data, or are you just hashing files?
So it depends on, so are you talking like everything is like a file can be considered data?
Yes, well, I can generate out of Excel, CSV, XLS, SLXS, whatever, right? Same data, but so with the example that was showcased, I can easily go in and tamper with all the GPS coordinates, and then I'll just timestamp it and pretend that I'm the originator. But the whole point is you're trying to solve the data, not the file. So are you actually solving the data or the file?
So when you look at how people can transact the data, we'll get more and more closer to where the point of origination is from. So what we're doing is that, like right now, we're working on a larger file set, so file blocks, because that's how companies right now are transacting these data feeds. As we go forward, we'll move more and more closer to the actual source of data. And yeah, you're talking about a per record basis.
Yes.
If somebody wants to do it on a per record basis, you could, but it's all the economics.
So a record is not the same. So generally, large companies, they have data warehouses. So it's system data streams, and then basically it gets transformed and loaded into the internal data warehouse.
Yes.
But the main thing is you're not capturing the source ID. You're not
In this case, so it depends on where they put the client, right?
Yes.
So that's the whole, it's a matter of where they're actually putting the client in there.
Yes, it looks like it has to be manually done rather than.
So they were just doing it manually on like uploading one file, but actually how we have it running is a fun, so we're using it currently in our real-time system that every time a file comes in and gets sent into the system, we're stamping at that time. We're just showing it manually. But so what the whole point of the client is that it actually, as soon as the data is originated and produced, that's when it's stamped. So depending on your application, so let's give a couple examples. If it's a MasterCard, when they swipe the credit card, you could at that point stamp that individual piece of data. Or if you're on a camera, you're making a video, the moment you hit save, you could then stamp it at that point. So depending on the users and how you want to create it, would be your own use case. So it's basically an economics game is on how close to the source you want to be, on how many times you're going to stamp this data.
So it's really dependent on who uses the application.
It's really dependent on how the people want to use the application, how they make, when they produce the data and when they want to stamp it.
So if they don't do it well, you can't guarantee all those things that you said. Because
Sorry, you know.
if they don't do it right, you can't guarantee anything. Like you can't guarantee integrity, you can't guarantee, you know.
Yeah, so like to the first question too is that we don't guarantee the integrity of each data line. We're basically stamping it as the company stamps it. At that point, that's when they declare this is the data that we're producing. And so if you look at complex, I'll give it a far-fetched example, a real example. If you look at the weather sensor, IoT, there's big problems that of all of a sudden the accuracy of that sensor is like, say it says it's in the room here is 28 degrees, but the sensor's off by 2%. We could not tell if the sensor has the accuracy rating that the 28 degrees is the right temperature, but it really should be 26. There's no way for us to actually verify that it's actually 28 degrees in this room. What Quadrant Protocol for is for commercial data sets and people are trying to transact it. So if all of a sudden a company, I'm selling these type of readings in all the buildings, I'd be saying, hey, this is a timestamp, this was the data that we produced, this was, and we're claiming that this was the state of the data at that time. Can Quadrant pick out that the accuracy rating on a sensor was wrong? No.
No, but how do you, so one of the problems you stated was you had four, vendors, 90% of the data was the same. You can't solve that problem with what you just showed.
So what you'd be able to do is you can start when they claim that this is their data, and then when we put algorithms on top, we would be able to start seeing it. Duplication is the problem in this industry, and then what we'll be able to do is you'll be able to run those algorithms against it. But the stamping would be, we're stamping this is our data here, and then now you can put in third-party algorithms to check the data. But yeah, we can't, due to the complexity that every data set is a little different, every problem is a little different. What the foundational step is just to say this is the status of the data. There's a lot of different checks that need to be put in on top of it. And that was so with IMDA, we spent months trying to formulate how we're going to commercialize services. Because there's all these companies coming up saying, we want to build AI services, we want to build microservices, but we need data to do this. And that's what that layer is about. It's about how do you create these services. So if the problem of data is duplication, well, we can enable that. If the problem is repetition or if it's accuracy, stuff like that, each of these algorithms has to be enabled into it, individually, because every data set's different.
Hi. My question is here. So considering that you're using an off-chain, on-chain kind of model for your product, so my question is that considering even if you hash the file and there's something which is centrally stored, right, which might be in a cloud or whatever, how do you authenticate the data is not going to be manipulated when it's centrally stored with you guys before it is retrieved? This is my first question. And secondly, I read a white paper, so I just want to understand the usage of your tokens, how it's going to be used in the platform, and as an investor, if I'm supposed to invest, then what is the utility I see?
Okay. So when you look at, so the first thing was on-chain, off-chain. Both parts, it's actually interesting. The reason why we created Quadrant was for the buyers. The buyers wanted to trace back where the data is coming from. So it's, the buyers had a big incentive or requirement, especially with GDPR in Europe, which is going to proliferate worldwide, is that people want to check, buyers want to know where that data comes from. So anything that's on-chain, they can trace. The problem is, as soon as something off-chain, then you can't control it, right? So, or you have no access. So buyers are the first ones to say, hey, we want everything to be on-chain. And we've actually talked to people who are purchasing tens of millions of dollars of data feeds. They're saying, I would move my clients onto this and make them all go onto it because they get the transparency on where the data comes from. So it's sort of a commercial requirement on the buyer side that they want to see it. On the vendor side, we thought, okay, they would then be forced to do it, right? Because if the buyer's not going to purchase from them, then they'll have to conform. But the ironic thing, or the interesting thing, is that actually the vendors too also want to be on-chain because they want to know where everything's going. Because as soon as they sell it to one person, and then that person does things that's off-chain, they have no idea. They're not getting paid. So all those nurseries and pioneers, what happens is that they spend money building data products, investing in the systems, paying to create these data feeds. They sell it to one person, and that one person then sells it to 5 people off-chain.
But then is it commercially viable to put so much data on chain?
So we don't put the data on the chain.
So then it can be manipulated or tampered with.
So if you stamp it and then you transact it, so then the vendor's stamping it to ensure this is the state of it. The
But
buyer
it's
is
essentially located with you guys.
sorry?
The data is essentially located
No.
with
The data, so the data is actually can be stored anywhere. It doesn't have to be on DataStreamX or.
But it is not on chain, right? So it's
It's not
stored
on
somewhere, let's say it's stored on cloud,
Yeah.
right? So then whosoever is accessing to that data. So I'm just saying that there can be a human angle to it and it does not authenticate that the data which was initially uploaded is being the same data which has been downloaded.
So that's the reason why you stamp it. That's what we're showing what the stamping client is. The vendor, the producer client would stamp it, and then that's the public chain. Anybody can verify it. The data that is transferred to the buyer 1, 2, 3, 4, they all should have it. If one of them has the wrong data, when they go to use a consumer client, they take the exact same data, they stamp it, they verify the hash they create with that data is the same one on there. So if it's not the same, it's very, I think we saw an example where it says it does not match. So then they can see right away that it does not match. And it could be malicious or even non-malicious. They just didn't, we actually see all the time when people will get, like terabytes of data being transferred. Sometimes files get missed. Manually, it's almost impossible to tell. So what you can do is, what you do is that you basically stamp it and then verify that you received the data in the exact same state. One little tiny error or difference will cause that hash to be invalid.
And second about the utility of your token. So what is the purpose of that? It is just the gas fee or it has any other purpose also?
Yeah, so there's 3 uses of the token. The first is a gas fee for the stamping. So when people want to use services on the chain, they do pay for gas. 2 is when we create the data smart contracts, is that people can use it as a mechanism for payment. And number 3, we spoke about ELONs. ELONs in reality are things like hedge funds or innovation centers. So if you're an innovation center or data scientist, you know that one of the things is you hate to do is pay for data when you have no idea if you're actually using. If anybody that sort of actually sells data, you hate hedge funds and you hate innovation centers because they're always asking you for free data. And because they're saying, oh, it's like a 6 or 12-month sales cycle. And so what we're going to be doing is doing a staking mechanism where companies, so there'll be different tiers where depending on how much you stake, it depends on which data sets become available. So what this does, it sort of helps data vendors get their data in the hands of people who actually can use it, and it helps innovation centers to start testing and trialing data in a more transparent manner and get access to these feeds prior to knowing if it's going to generate alpha or solve some issue. So yeah, we'll be using a staking mechanism there as well.
Thank you.
Mike, if you mind. Question in terms of cross comparison, vis-a-vis yours, to data, for example, consensus and the others. What you bring something new? What is the distinction that you bring to the table that others don't have it, and you have more dynamic kind of features and capabilities?
In terms of comparing against other...
Consensus.
Consensus models?
Protocol.
Yes.
All other protocols.
So one of the key things that is that there's different layers of protocols. There's layer 1, which is block creation, and layer 2. We're a layer 2 protocol. We're a data protocol for the transaction and stamping of data. That's what we are. We are not a new consensus mechanism. We're using proof of authority, and the reason is that it gives us the characteristics that we need and our clients need, but we're not like, we didn't create something that competes against proof of work or proof of stake. We're a data protocol.
And the other thing is that in case that in the context of those you are not in other words, availability, that the drawers is still, the stack will need to be open for the next improvement or the next initiative. Do you have that specific requirement that you think that you would like others to contribute and play a part with you?
Yeah, so the best way to engage with us on the innovation side is on the Elon side, how people can use data. We're seeing more and more innovation coming out, basically from all ends, from the consumer end to the business end. So to work with us is to, what we want to do is improve on how people use data and the innovative use cases.
Yeah, I have several questions, so I will start with your tokens. So you have two kinds of tokens, which is quad and equal. Seemingly, I have a feeling that it comes from this guy called Elon Musk and the staking. So your quad is used in the internal network, and you say that this is convertible, maybe in the future. I don't quite understand why you need this.
Okay.
So hang on, let me continue, still on token. I haven't gone to the AI part,
Okay.
so that will be part 2.
All right.
So now, as in any tokenomics, there's this thing called wallet. So wallet is one sheer place to hack. Yes, trust me, has been done since day one. So you accept any wallet. I suppose you want to reach out to the world, to everybody who owns the wallet. So you mentioned about blockchain.info, which actually has a lot of outage since, historically speaking, this brief history. And you also accept like JAXX, JAX or whatever, which is actually a closed source wallet. Previously witnessed.
So I'll stop you there. So your question's twofold. One is, why is there a dual system? And 2, wallet security.
Yeah, it's quite conflicting. And you even mentioned about you will accept any wallet, whether it's a multi-sig or non-multi-sig and whatever platform, blah, blah, blah. So I sincerely like to hear what is your rationale behind.
Okay, so 2 things. So with us is that we do have a 2-token system. The first is an ERC20 token on Ethereum. That is the way that we conducted with our ICO. That allows a lot of people are familiar and have the wallets that they can easily hold the ERC20. So that's the one. So that's when we're doing our ICO. You can purchase that. To get access to the net, we just have a gateway between. And the reason is that the Ethereum mainnet is very slow. You cannot run any application on there in the affordable manner, especially if you've been transferring in the last week, gas prices on this. Right now, Ethereum has a lot of growing pains. So what we've done is that we've created a sidechain, our own mainnet, and there's a gateway between the two. So if you hold just one, then you can easily use it if you want to either purchase it easily off of different exchanges and so forth. In the future, if it goes to an exchange, you'd be able to do that. But for people using the system, you just transfer it into our net. It's a one-to-one ratio there. So what we do is we get the best of both worlds. Our customers, our clients will be able to easily transfer the ERC20 token, but when they're using it within as a utility token within our network, they just transfer over to Quad. The wallet-wise, same thing. Having if you are storing, so you're a company who wants to purchase data from the network, let's say right now you want to purchase tokens and then in the future you'll use them, then you can then store them on any ERC-20 compliant wallet. So if you have a treasure or so forth, you can just hold the ERC-20 token in a secure wallet.
So you don't really care whether is it safe?
Of course, anybody who's in blockchain knows the usages of a wallet, but I can't comment on every wallet that's out there, which ones are the best ones to use.
That's a different debate.
Yeah.
Anyway, so my second question is about this thing called deepfakes or whatnot. This has existed since actually quite a while ago.
Yep.
Now, the point is not about whether it's deepfakes or how you authenticate all these. If you're in AI, you should know that there's this thing called GAN, GAN. So the generative adversary network.
Okay.
So I can use a gun and generate any face, as many faces, whoever, whenever. I can verify them, put it into 1 million ways. It's very simple. It's only algorithm. And in that 1 million faces, not necessarily put it, I can create a fake human, which actually exists in the real world. And if I try to do some pokey business, I will transact this everywhere, which is not difficult. So how does your stamping mechanism come to authenticate all this kind of thing? Because as you mentioned earlier about the IoT sensor, which is 2% out or whatever, you can't control that, which I totally agree. But what is to prevent this kind of fraud, which is all over the whole internet?
Alright, so what it is, so the reason why I use a deepfake when it's that someone who's broadcasting, someone who's sharing, that's when you want to check it. So you're right, somebody could make a fake video, and then if anybody else wants to distribute that fake video, you could. But what happens if you don't want to? What happens if you do want to verify, is this actually real in that? So this was just an example to show that if you're in an ecosystem where you want to trace things, where everybody wants to actually verify first before consuming it, that's what the ecosystem is for. But as was mentioned by one person before, outside of the ecosystem, you're right, you can fake whatever you want. That's what we're trying to do. We're trying to create an ecosystem where if you're included inside it, you'll be able to verify it. As soon as things are off and outside, that's what the Wild West is, and that's why we're trying to get people coming into the ecosystem. Any other last questions? Oh, there's some.
Hi. It's a pretty interesting presentation, and particularly content authentication. I understand it's a big issue. So the protocol, the chain solution, it brings in a lot of trust for the content viewers from the content providers side. However, my query is about the packet which the metadata packet which is to be hashed. That will be only hashing the packet size, but the packet level. But do we have the authentication, or what we say, the hashing of the content inside? That's one. Secondly is about there's typical issues in like what the content platforms like Facebook and all are facing these days of the fake contents. So do we have any vision, or you have planned to bring in some capability in plugging those loopholes where you authenticate every user by their logins and you can trace out, or it's some kind of thing in removing the fake news issues?
So the interesting thing, actually, we focused on this presentation talking about authenticity and data and how. But the ironic thing, that's actually just the first building block in Quadrant. Quadrant is all about actually mapping and comparing data sources. So when you have 12 different people who are providing data in, that they're going to get aggregated and then mapped together. So that's actually approximately the main part of Quadrant protocol. And so when you have 12 vendors and you create one product, how do you when the next person purchases it, how do you trace that through? And that's what we're building, that's what we release in the future. The authenticity is just step one. Because what we found is that you can have all the data in the world, but if you don't start with the foundation of it being authentic and stamped into the system when it comes into the system, that's when you go to problem. So that's what our first thing was. So like with Quadrant, the authenticity is just step one. And then it's how you go and now combine it and then produce and combine taking data sets and so forth. And so with authenticity, I know we focused on it a lot here, and there's a lot of interesting things we do. And we're going to see people using the protocol itself in interesting ways that way. So if Facebook could use something like this to solve different problems. When it comes to authenticity of like deep fakes and all that, there's more than just one problem. It's not just like the file itself. The file itself is only one step, but there's all these like fake bots. Malicious people will still be malicious, and how do you plug those holes as well? So what we're saying is that with like the stamping, it's one step to sort of help in the fight against fakes, but there's so much other work that has to be done, because if people are being malicious, they're going to be malicious. And so how do we stop those? There'll be other solutions for that.
That's great. Just one thing which you mentioned in your response, that it can have interoperations. You might have a hub which connects over more than 12 or 14 content providers. It can also happen that there are other such hubs. So we plan of any interoperability, opening, stacking, and all those things.
Yeah, so again, especially IoT, you see that in the structure of it. Usually there's like gateways in that all these hubs the sensors will feed into a gateway. And so you could actually stamp it and put our clients in at that gateway, or you could then put it at the master. So if all these gateways then send into a centralized server, then you can stamp it there as well. Yeah, there's many ways that it can be deployed. And so our first thing is to look at, our first industry we're looking at is the location data industry, because that's where we transact it and we're solving the problems for that. But then as we go to the future, as we go forward, we're going to start seeing other ways, like that hub type scenario where you have an aggregator inside an internal system of a company where you'll want to stamp it throughout, and you could use Quadrant for that.
Thank you.
That's it. Thanks very much for coming out. Hope you found it interesting. And if you have any other questions after, please come talk to any one of us. Thank you very much.
Thank you.